Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu, and today we're going to talk about paramagnetic and diamagnetic atoms and how to determine that. So this is a small topic that on top of the electron configuration. Okay, so let's hit on topic. Before we talk about these two concepts, we need to know what are paired electrons and what are lone electrons. So if we look at the electron configuration of hydrogen, it only has one electron, so it's 1s1, right? So s orbital has only one orbitals. So when we have one electron in one orbital, we can write an electron using a up pointing arrow showing spin up. Okay, spin up electron in one orbital. And this spin up electron does not have its neighbors. So in other words, in this electron orbital, there are only one electron here, although it can accommodate two. So for this one electron, we call that lone electron. Lone electrons are electrons that are only one electron in the orbital. If we take a look at helium, where we have two electrons and it's 1s2. So in this case, for that only, the 1s orbital, we will have a one spin up electron and one spin down electron. There are two electrons in this orbital, and this orbital is fully occupied by electrons, and we call that paired electrons. So there are two electrons in one orbital. Those two electrons are all paired electrons. Besides 1s, or besides s orbital, we can have p orbitals that have paired electrons and lone electrons. For example, nitrogen, here is electron configuration: 1s2, 2s2, 2p3. For 1s and 2s, it has fully occupied by electrons, it's fine. But when we look at 2p, the p orbital has three orbitals at the same energy level, right? So we call that degeneracy orbitals, but that's fine. For these three p orbitals, when we have three electrons to fill in, these electrons want to occupy as many orbitals as possible. So it will not form a paired electron and a lone electron. Instead, like it's showing here, it will occupy three different orbitals with all lone electrons. So in nitrogen, we have three lone electrons in the 2p orbital. If we take a look at fluorine, whose electron configuration is 1s2, 2s2, 2p5. Of course, 1s and 2s are all fully occupied by electrons. For the p orbital, it can maximum hold 6 electrons, but now we have 5. So after putting 3 electrons in as lone electrons in p orbital, we have 2 electrons left over and it needs to be squeezed in the whatever leftover orbitals. So we have 2 pairs, in total 4 paired electrons and 1 lone electron. So when we decide whether it's a paired electron or lone electrons, we need to first have the electron configuration, write out the valence electrons and see how they occupy orbitals in reality. Okay, so let electrons occupy as many degenerate orbitals as possible. Well, degenerate orbitals are orbitals that have the same energy level. In other words, the 3 orbitals in p orbital, or the 5 orbitals in d orbital, or 7 orbitals in f orbitals. Yeah. After we know paired and lone electrons, we can determine whether an element is paramagnetic or diamagnetic. So paramagnetic means the ion or element has lone or unpaired electrons. So unpaired electrons and lone electrons are the same concept. So in orbital diagram, paramagnetic elements are attracted to magnetic fields, and diamagnetic are ion or element that has no lone electrons. Okay, in other words, all electrons are in pairs. So it does not attract to the magnetic field. Actually, it repels to the magnetic field. An easy way to remember is if you see the diamagnetic, it has prefix of Di, right? When you say Di, there are 2 electrons, so everything is in pair. Let's take an example to determine whether an element or an ion is paramagnetic or diamagnetic. So is chromium atom paramagnetic or diamagnetic? Now how about iron and how about copper 1+? You can take out the spreadsheet and try to work it out yourself first. All right, for all of these paramagnetic and diamagnetic questions, we need to write out the electron configuration correctly, right? So that is the topic in our previous video. I attached the diagonal rules here and also the part of the periodic table showing where these atoms are. So these atoms are all transition metal atoms in the 4th period. So when we write the electron configuration, we can write bracket argon and then write, the electrons on starting with 4s. For chromium, it has argon 4s1 3d5. Okay, it's an exception because the 3d is half filled. We prefer to have the 3d5 and 4s1 configuration. So s orbital has 1 electron. When we have 5 electrons in d orbital, these electrons want to occupy as many orbitals as possible. So all of these electrons actually are lone electrons. So it's paramagnetic. For iron has electron configuration of argon and then 4s2 3d6. When we have 6 electrons in the d orbital, so we have 1, 2, 3, 4, 5 d orbital. First, we're filling all d orbital with lone electrons, and then we used up 5 electrons. However, now we have 6 electrons, so we're just filling 1. Squeeze 1 electron with any of these 5. So now we have a pair, 2 paired electrons, and then 4 lone electrons. As long as we have lone electrons, it's paramagnetic. So iron is paramagnetic. For copper plus, we first need to write the electron configuration of copper atom and then lose the outermost electron. So copper atom has argon 4s1 3d10, lose the outermost electron in 4s1. Now copper 1+ has the electron configuration of argon 3d10. Well, the d orbital can maximum hold 10 electrons, and now we have 10 electrons here. So it's diamagnetic. Every electron is in pairs. It's fully packed. So now, hopefully with these examples, you can now identify whether an element or ion is paramagnetic or diamagnetic. And then this is the end of this video, and I'll see you next time. Bye.